Okay, here are the 5.3 notes, last couple of pages here. So in section 5.2, we talked about end behavior using the leading term of a polynomial and the coefficient. There's a review of this at the top of this page. Again, I'm not going to read this to you. We've also talked about increasing and decreasing. Remember that when we talk about increasing and decreasing, we define it, we look at the function, so we're using the y values to decide if it goes down to the right or goes up. If it goes down as we move left to right, the function is decreasing. It goes down as we move left to right. If it goes up as we move left to right, it's increasing. And we go ahead and divide our x-axis based on where we're changing from increasing to decreasing or decreasing to increasing. Those places where we are changing are called the turning points. So they are the little bottom dips, bottom of the valleys, top of the hills. Those are our, local extrema, the local maximum, local minimum. Okay. We know there are always one fewer turning points than the degree of the polynomial. So the one we're looking at here is a 4th degree polynomial. Right? The highest exponent, the highest power is a 4, which means we are going to have 3 turning points, and here is our 1, 2, 3 turning points. Last thing we're going to talk about in section 5.3 is using the intermediate value theorem. Basically, it says if I evaluate the function at 2 different numbers, one's negative, one's positive, these are all polynomials, so we know they are smooth and continuous. There's got to be a 0 between the two. So we are going to take a look at f of 3. I got 3 to the 3rd minus 5 times 3 squared plus 3 times 3 plus 6. 3 to the 3rd is 27 minus 5 times 9 is 45 plus 9 plus 6. We get a value here of negative 3. When we plug in 4, we've got 4 to the 3rd minus 5 times 4 squared plus 3 times 4 plus 6. 4 to the 3rd is 64. 4 squared is 16 times 5. We've got minus 80. Plus 12 plus 6. Which gives us a value of 2. Negative 3. Well, negative 3 is negative. So f of 3 is negative 3. F of 4 is positive 2. So we know the polynomial crosses the x-axis. Between x equal 3 and x equal 4. So there's a 0 there. Okay. Example 3, you will definitely be asked to do this on the midterm. This just makes sense. You make sure you really understand what is going on, and you can go forward and backwards. So I have this intercept, negative 3, 0, which means next x equals negative 3 is a root or a solution, which means x plus 3 is a factor. I have 2, 0 here, which means x equals 2, which means x minus 2 is the linear factor that goes with that. And I've got 5, 0 here. X equals 5. X minus 5 is a factor. So my function, sum A times x plus 3, and we're looking at the multiplicity. We go straight through at negative 3, so this has multiplicity 1. I've got x minus 2. This touches and bounces off, so that one definitely has multiplicity 2. And then I have x minus 5. Again, we go straight through, so that one's got multiplicity 1. Right now I have a 4th degree polynomial, and this makes sense. Both ends are pointing up. I know I've got an even degree, and I know my a had better be positive. So how do we figure out what a is? I am going to go ahead and take a look at my y-intercept. Which is 0, negative 2. Which means when I plug in 0 for x, I'm supposed to get negative 2 for y. So we should be able to find the a that makes this true. 3, I got negative 2 squared, which is 4, times negative 5. I get negative 2 equals a times 60, negative 60. Divide both sides by negative 60, and I do get an a that's positive, positive 1 over 30. We're going to go back up here, and we are going to write our polynomial function. Oops, sorry, 1 over 30. 1 over 30 times x plus 3 times x minus 2 squared times x minus 5. This shows that I understand how to use a graph to find the zeros, write the linear factors. I definitely do not need to multiply this out, nor am I going to change my fraction to a decimal. It really is a whole lot easier to work with fractions than it is decimals. And that's it for the 5.3 notes.